Okay, so next up we're on to question 10 of the VCAA 2010 Methods Exam 1 paper. So this one, we've got a line y equals ax minus 1, that's a tangent to the curve y equals x to the power of a half plus d at the point 9, c, where a, c and d are real constants. And we want to find the values of a, c and d. So let's unpick it first. So y equals ax minus 1 is a straight line. Obviously, because that's a tangent to y equals x to the power of a half plus d. This one here is simply y equals x square root plus d at the point 9, c. So if we quickly graph that out, we could say d is any point, and we've got, say d is positive, it doesn't really matter. We've got that sort of thing looking at it, and our line here at x equals 9, so something like that. That's our green line ax minus 1. So the first thing I'm going to do is I'm going to find dy dx. So dy dx equals, so we had x to the power of a half, so power out the front, 1 off the power, and plus d is a constant, so it goes to 0, so I could write plus 0 there if I wanted. And then my dy dx is just equal to, so the negative a half just turns it on to 1 on 2 root x is dy dx. And we know that for this to be a tangent, for the green line to be a tangent to this, the gradient of our line must be the same thing. And the gradient of the line is simply that a term that sits there. So that's m, or the gradient. So we can say that this is equal to a, where x equals 9. So we're getting that from that point there. So therefore, a equals 1 on 2 times the square root of 9 equals 1 on 2 times square root of 9 is 3 equals 1 on 6. So now we've already got our value of a. A equals 1/6. So I might just put that over here. A equals 1 on 6. And that's one of the pieces of information we needed. So now we've still got to pull apart C and D. So C shouldn't be too difficult to find out. So if we go back, next up, yes, so we should be able to find that exact point 9, c. So I might just put that in black here, 9, c, because the value of c is the same value of the y in our green equation when x equals 9. So just to make that clear, we've got y equals c for x equals 9. So we sub all that into our green equation, and we've got y equals a, which we've found, a sixth, x, which we're going to put in as 9, minus 1. So that equals 9 on 6 minus 1, and we might put that minus 1 as being minus 6 on 6, and here we'd just get 3 on 6 being left over, which is 2. So the next piece of information we've found from that is that C equals 2. Alright, and that's because that green line there is equal to C at the y point. I'll do it in orange. That's equal to C, this value here, at x equals 9. So we've found A and we've found C. So the next thing we need to do is we need to go back and find D. So if we know C equals 2 when x equals 9 along this blue curve, we can use this blue equation to find out what D is. So we're going to use our blue equation and we're going to sub the point 9, 2 into the blue equation y equals the square root of x plus d. So we've got so we have y as being 2. So let's put that in. So 2 equals the square root of 9 plus d. Therefore, 2 equals 3 plus d implies that d equals -1. So that's the third piece of information that we needed to see there. So now we've answered A, C, and D. So that's the final answer to this question.